The way getPID works is supplied by the C library. And if we go look inside the C library and disassemble it and look for the getPPID function to get the parent process ID, then we'll see that it moves hex 6e into EAX and then performs a syscall. So this syscall is like an interrupt. It gives the kernel control. The kernel sees that the thing being requested is whatever 6e means. And it turns out that 6e means get the parent process ID. So the kernel arranges for the parent process ID to end up in register EAX, and then getPPID returns. Anything a program does that needs to reach outside the program's memory, the process's memory, has to at some level involve a system call. For example, opening a file will need to involve a system call. In portable C and the C standard, the way that you open a file is with fopen. But fopen is the portable variant that doesn't correspond to exactly what different operating systems do. Turns out that fopen on Unix uses the system call open. And you can see the arguments are a little bit different, and the way it behaves is a little different. And also open, instead of giving you a pointer to some structure, just gives you an integer back. In general, system calls just give integer values back. The way you can tell the difference between whether the function that you're using or want to use is in the C standard library or part of the operating system standard is when you look for man fopen, the page will say fopen3. So let's try that. So if we say man fopen, then we see at the top of the page it says fopen3. 3 means from the C library. In contrast, if we do man open, then we see open2. That's because 2 is a system call, and 2 means system. System calls always just return integers, and they return integers even if the call fails. So when you use open on a path that doesn't exist, suppose that no such file .text doesn't exist, then the result that you get back from open is the integer -1. Right? So 0 and positive integers mean success from open, whereas -1 means that it didn't succeed. Right? There's no exceptions like in Java or anything like that. We have to check manually for that result. Right? So typically a system call returns an integer, and typically a -1 result means an error. And to get more information about the error, then your program has to look in errorno. So C programs that are using system calls directly often have this sort of pattern. Here we're calling the open system call. To get f, if f is -1, then we handle the error by printing an error and giving up. So here we print to standard error, which is, as we'll talk about later, where you write errors and some information about the error. The str error function takes a errorno number and translates it to a human readable string to print there. And then this program exits. Otherwise, we assume it keeps going, working with the function. But this pattern, if you have to put it at every system call, is really a pain. And in fact, the pain is worse at the true system call level. If you go look in the implementation of open, then it looks something like this. Mostly it moves number 2 into EAX and then performs syscall. So the operating system, the kernel, sees 2 and knows that it's a request to open a file. What it returns isn't exactly -1. It returns a value that might be an error code. Right? So 2 meant open, and if it returns something in the range -1 to -496, that means an error. So at the raw syscode level, it's even worse how to interpret these values. So what the code here in the C library will do is, if it's in that range, it jumps to this other code. Otherwise, it can just return because it must be a valid result from open. But if it's an invalid result from open, then well, errorno is a global variable that's in a shared library, so of course we have to do the position independent code thing to get the address of errorno, and then we negate EAX, so that changes it to a number from 1 to 4096, which turns out to be a range of valid error numbers, stores it in the global variable errorno, and then resets the return value to be consistently -1 for all the errors. So to make it even easier on us than using the C libraries wrapper on system calls, we will mostly use csapp.h and csapp.c. csapp.c defines open with a capital O. To be just like open, you see there's an extra argument. That's because open has an extra optional argument. And it's going to call to the normal C library system call wrapper. But if that gives an error result, then it will print an error message and exit for us. right? Otherwise it returns the result. So everywhere in the slides and example code where you see a capitalized thing that looks like a system call, that is the csapp.c wrapper on the system call. So we don't have to constantly put error checking code everywhere.